All right. Here's example number 2. They've asked us to determine if these examples are similar using our side similarity. So now remember, similarity, this is going to be different than congruence. We don't have to prove that they're the same. What we have to do is prove that all three sides are proportional. Okay, so again, all I'm going to do is I'm going to make a proportion problem. Now this time you do need all three. So we're going to make 3 fractions right there. I'm just going to call this our top of our fraction and our bottom. Again, it doesn't matter which one you put in top and bottom. So just know you just have to be consistent. Okay, so I'm going to use these 3 for my top, these 3 sides for my top right here. So I've got a 3, I've got a 5, and I've got a 4. Now I've got to line them up with this triangle. Now note, they didn't tell me that these are similar. I have to tell them if they're similar. So they didn't tell me which side was similar. I'm just going to look at the values. Notice how 3 was my smallest side. That means it has got to be proportionate with the smallest side over here, or that 6. So I'm going to put the 6 under that one. 5 on this triangle, that was my largest side, my longest side. So I'm going to put a 10 over there. And then the 4, that means lines up with the middle one, which is 8. Now, looking at these, we can actually tell right away that they are proportionate. If they're harder fractions, I would just use a calculator. In fact, let's even use a calculator for this one, and I would just get the decimal. So I'm just going to do 3 divided by 6, which is 1/2 or 0.5. Okay, so they want to know, is that equal? Again, these are kind of all question marks right now. We don't know. We're trying to see if they're equal. So 5 divided by 10 is also 0.5. Is that equal to 4 divided by 8, which is also 0.5? So yes, these are indeed proportionate. So that means that they're similar. So again, we're going to line them up right here. And we're just going to call this triangle anything we want, triangle PQR. And we're going to say that that's similar too. Now between P and Q, that was my smallest side. So we're going to go to our small side over here and do ST. And then Q to R was that one, so T to U right there. So PQR is similar to, triangle STU right there. Okay. All right, now let's look at this one. I'm going to try and get a fun color. Let's do that nice, pretty color. Okay. All right. So now, again, we're going to see if these are proportionate. So we're going to set up a proportion. Again, just call one the top, one the bottom. It doesn't matter which one, and throw your numbers in there. So on my top, I'm going to write a 30, a 35, and a 32. Okay, now I've got to line them up with values that correspond in the bottom. So 30, notice this was my first one. 30 is the smallest number in this triangle. Okay, so the smallest number over here is going to be 24. 35 is my biggest number. 28 is going to line up with that one. And then 32 is right in the middle, which 24, 28, so 25 is going to be right in the middle there. All right, now again, just grab your calculator. These are kind of messy. Some of you can do them and say 5 over 4 stuff. But I would just grab a calculator and do 30 divided by 24, which is equal to 1.25 right there. Okay, again, I'm going to maybe go red. We're actually seeing if we don't know that they're equal. We're trying to figure out, are they equal right here? Okay, we're going to go back to our nice fun color. And then 35 divided by 28 in my calculator is also 1.25. And then I'm going to look at 32 divided by 25, which is 1.28. Oh, it's close, but they cannot be close. They have to be exactly the same value, like to as many digits as your calculator will do. So even if they're close, it looks like they're pretty similar. They are not similar. So this one is a no answer. And you love the no's because guess what? You don't even have to do a similarity statement. No is just the end, and you're done with that problem.